This homework example came in as a question from a student. Thank you to the student who sent this. It's a question about simplifying a radical when there's an imaginary component. The imaginary component means that there is a negative inside the radical. Here's how you would approach this. We've got two pieces going on. First, we've got this negative inside the radical. Let's just make an easy example, like the square root of negative 9. The square root of negative 9 could be defined as the square root of negative 1 times the square root of 9, and by definition, the square root of negative 1 is I. So we'd call this I times the square root of 9, 3, or just 3I. That's the square root of negative 9. So this square root of 931 is saying that we've got I times that square root of 931. The next step at simplifying the square root of 931 is to break it down into a perfect square, or a factor that has a perfect square. Here's what I mean by that. We're looking for 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, etc. Any of these values, 4, 9, 16, 25, 36, 49, 64, 81, 100, etc. Any perfect square that'll divide into 931. So what I would do on a calculator is 931 and try dividing by 4. We don't get a whole number, right? 931 divided by 9. Try that on your calculator. It doesn't come out. Divided by 16. It doesn't come out. Divide by 25. 25 does not go into 931 evenly. So in other words, if I did 931 divided by 25, I can't reduce that, right? By 36. 36 doesn't go in evenly. And finally, on the calculator, when I do 931 divided by 49, I get that works. And 931 divided by 49 gives us 19. 931 divided by 49, or maybe think of it this way, 931 divided by 49 is 19. Any way you look at it, 931 divided by 49 gives us 19. But what was so special about the 49? What's special about the 49 is that it's a perfect square. So when that perfect square 49 divides into 931, I get this 19 as a remainder. But that 49, the square root of 49, let me erase some of this. The square root of 49 is a perfect square because 49 is 7 squared. Square root of 49 is the square root of 7 times 7, so that's a 7. So now I can take out a 7 . So a better way of writing that would be 7i, right? Times the square root of 19. So we end up with 7i times the square root of 19. I hope that helps you with this problem. Oh, and let me show this. Oops, didn't mean to move the problem. We'd have I times the square root of 49 times 19. That's that step in between to get the problem as we go. But I hope that this explanation has helped a little bit more with simplifying radicals, or with working with complex components in a radical. That's -1 in the square root, or the I. But if you do have further questions about this type of example, I hope that you'll let me know. We could go over it in more detail if you have any questions.